Hey guys, hope you had a great weekend. Let's go ahead and get started on this engage. So this is about a bungee jumper. Let's pretend it's Briar, just for the fun of it. Hope you're there today, Briar. You're going to be bungee jumping, and we're going to model your path using this function, h of t. So go ahead and pull up a new graph, and then you're going to type this function into your calculator. But remember, instead of using t, you need to use x. So we're going to have f of x equals 5x cubed minus 38x squared plus 28x plus 189. Okay, and then once you get that pulled up on your graph, go ahead and hit Control T to pull up your table. And you should get 189, 184, 133, 66, 13, 4, and then 69. If you don't have those table values, then you type something in wrong into your graph. Okay, so now I'm going to show you how we can get a good graphing window for this function. So this function goes from 0 to 6 seconds, so that's what we're going to change our x-min and x-max to. On your calculator, you're going to hit number 4, or hit menu, and then number 4 window, and then window settings. And then you're going to change your x-min to 0 and your x-max to 6 because we're going from 0 to 6 seconds. And then let's go ahead and change our x scale to 1 so we can see what's happening at every second. And then the y minimum is going to be 0 and y max is going to be 200. Because we can see from our table that the maximum height so far is at 189, but we're going to go ahead and extend it a little bit further just so we can see the full picture of the graph. And then let's keep the x scale at auto. Okay. So now you can see a better picture of Briar's path when he's bungee jumping. Okay, he's going to start up here, go up a little bit, and then go all the way down. Okay, so let's go ahead and write down what that window was. So my x-min and max went from 0 to 6. And then y-min, y-max went from 0 to 200. Okay, how tall was the platform from which the daredevil jumped? How do you know? So before Briar jumped, that would be before our time has started. So it would be at 0 seconds. So the height was at 189 feet when time equaled 0 seconds. So before our time even started, Briar was 189 feet off of the ground. Now let's move to question D, and we're going to look at that on our calculator. Jump, also known as Briar, into the air before falling. So really we want to figure out the maximum. Okay, we know he starts at 189 feet, but we got to figure out, well, how much higher did he go before he started falling? Okay, because if you're jumping, you're going to go up into the air a little bit before you fall. So we can do that two ways. We can look at our table and our graph. Let's go ahead and look at our table first. So on your calculator, go ahead and hit Control T to pull up that table again. But it looks like 189 is the most, or the highest that we have. But I know between 0 and 1 second that it actually has to go higher than that, okay? So in order to look at that, we need to change our table settings to go from 1 second to increase by every 10th of a second. So go ahead and hit Menu, and then go down to number 2 to table, and number 5, edit table settings. So you want to start at 0, but instead of increasing by 1 second, let's change that to a 1/10 of a second. Now we can look at what happened at every 1/10 of a second. So I'm going to keep scrolling until I get to the maximum. And it looks like 194 is going to be our maximum, around 0.4 seconds. Okay, let's confirm that with the graph. So hit Control-T to get out of your table. And now we're going to look at the maximum value on our graph. So hit Menu, Analyze, and Maximum. So we're going to take this little arrow and scroll to the left, or dashed line, and we want to go to the left of it. That's what lower bound means. Select it, and then scroll to the right of it and select it, and it confirms what we found in our table, that the maximum was at 0.4 seconds and 194 feet. So if the maximum was at 194 feet, and we started at 189, I would subtract the 2 to figure out how many feet did he jump. And that would have been 5 feet. Okay, now we're going to do question E. What is the closest the bungee jumper came to the ground? After how many seconds did this occur? So you would go through the same process that I just showed you, but this time, instead of finding the maximum, which is what we just found, you'd be finding the minimum. So you do Menu, Analyze, Minimum, and you should get the value at 4.67 seconds. Briar would have been 0.259 feet from the ground. So 2/10 of a foot from the ground. So that's pretty close to the ground, okay? And that would have been at 4.67 seconds. So remember that this is your seconds, the first value is your x, and then this would have been feet, the y. Okay, it's very important that Briar did not come to 0 feet, because that means his face would have smacked into the ground. All right. Remember, whenever we did that Barbie bungee activity when you were a freshman, you had to calculate how close you could get the Barbie to the ground without touching it. And so this is the same thing. Whenever you're bungee jumping, you want to make sure that you don't come too close, because that would be very bad. All right, question F. At t equals 5 seconds, was the bungee jumper falling or bouncing back up? Explain. So go ahead and pull up your table again. And since we know from the last question that our minimum was 0.2 feet, so basically back up here, Briar was the lowest to the ground at 4.6 seconds with a height of 0.2 feet, that was the minimum. So since 5 seconds is after that, like right here, he would have had to been bouncing back up. Okay, so you could have went to your table to see that, or to your graph. Because at 4.6 seconds, he was already at the lowest height, so 5 seconds means he would have been bouncing back up. Okay, last question, question G. At which intervals was the bungee jumper falling? So if I scroll back up here to the graph, we know that he starts falling up here at this maximum value, and then he stops at this minimum value, which was right here. So in between these 2 time intervals is when Briar is falling. So we need to look at the time intervals for our maximum and for our minimum. So let's scroll down to these questions. So at the maximum, what was our time? And that was at 0.4 seconds. And then our minimum was at 4.67 seconds. So the intervals would be from 0.4 seconds, comma, to 4.67 seconds. And that would be the interval from which Briar was falling while he was bungee jumping. Okay, I was going to send that for homework, but I know it's been a while since y'all have graphed or done anything with the table, so I wanted to go do that together. Go ahead and get out your notes, and we're going to talk about some vocabulary words that came up with this engage activity. So we talked about increasing. Increasing is whenever the graph is going up from left to right. So if we go from this picture, I'm going to highlight the sections of the graph that's increasing. So even though this graph's pointing down, if I'm reading this from left to right, this blue section is actually increasing, and then it starts again here at 1. So we could say from negative infinity to negative 3, it's increasing, and then unioned with positive 1 to infinity, it starts increasing again. There's 2 different sections where it would be increasing. All right, now let's look at decreasing. So this is when the graph goes down from left to right, just like you read a book. So from negative 3 to positive 1, this graph is decreasing. So we would only have one interval from negative 3 to positive 1. Okay, in that bungee jump activity, we talked a lot about maximum and minimum. So our maximum is going to be the highest value. And then the minimum is the lowest value. And then we're going to sketch and find if there's a minimum or maximum of the function f of x equals x squared plus 3x plus 5. So let's go ahead and graph that. I would go ahead and just pull up a new graph. You should get a parabola that looks something like this. Alright, so this graph does not have a maximum because it just keeps growing and growing, but it does have a minimum value right here. And just like what we did on that bungee jump activity, you could do menu, 6, analyze, and then I think it's the second option to do minimum and find exactly what that coordinate is at. And you should get that it is at the value negative 1.5, comma 2.75. Side note, whenever you do this, it's going to be on a Google slide document. Most of these questions you can just type into the text box, but there are some that you're actually going to have to graph just like this. So somewhere on your paper to the side, let me just come down here. On your Google slide assignment, you're going to hit insert, line, and then scribble. Okay, and it looks something like, well, that was a bad example. Maybe something like this. There's a picture. Anyways, it's just a scribbly line. And what that scribble line allows you to do is you can draw your own shape. So you can go on your graph on that Google slide and sketch what that picture is going to look like. Okay, I don't expect this to be perfect, but just get the general shape of it. So anyways, whenever you do your worksheet here in a little bit on Google Slides, make sure you do insert, line, and then scribble, and then that way you can sketch what your graphs look like. Okay, back up here to the top. Last one is asymptote. An asymptote is a line that approaches a value but never reaches it. So, for example, this graph has an asymptote at x equals 0 and at y equals 0. Okay, it's whenever a graph starts to level out like this, it gets really, really close to a certain value, like here at 0, but it's never going to reach it. Remember, I think it was last year maybe, we did that free throw activity where if you miss a free throw, you start leveling out at 100% because you'll never get back up there again. So that's an example of an asymptote. It's going to get really, really close to a number but never reaching it. Alright, that's it for the notes. Hope you guys have a great day.